So today we're going to be looking at catching in our AS class. So what is catching? What does it entail? So I'm going to give an illustration to explain what catching is. So let's assume you have a reading desk, and your reading desk is in a separate room with your library. You have a reading desk and you have a library. So there is a place you store your books, and that is in another room. So most time what you do is that when you want to read a particular book, maybe a book A, you have to go down to your library, pick up the book, then take it down to your studying desk and study. And when you're done with that book, you take it back to the library. And what if you want to continue with that same book the next day? What happens is that this is what you do. You pick up the book from the library, you take it to your reading desk, and after reading, you take it back. The next day, you are still picking the same book. You go back to the library, pick it up, come back to the reading desk. Then following day, you continue the same sequence because you're still reading one particular book and you're not done with it yet. So don't you think it would have been wise for you to have that book on your reading desk so that when you're done studying for today and the next day you want to continue, you just go back to your reading desk and you pick up the book instead of going back to the other room where your library is? What does that save you? It saves you from some stress, right? To go to the other room to pick up the book. And that is what catching is in computer science. So in computer, there are some stuff that we also needed in our computer system, some data that are reusable. So those data, instead of fetching those data often, the data is fetched and it is stored in a temporary memory. So when it is needed, the data is just being reused. There is no need fetching up that data. So it makes life much more easier. It makes the processing much more, it makes the system much more efficient so that you don't do too much of processing or too much of request making. So that is what catching is. So in computer, a cache is a high-speed data storage layer which stores a subset of a data, something that looks like the data, or even the data itself, a simulation of the data, transient in nature, so that the future requests for the data are set up faster than it's possible by accessing the data's primary storage location. So caching allows you to effectively reuse previous or retrieve computed data, and that is what I've explained earlier. So how does it work? I just explained how it works with that illustration. The data in a cache is generally stored in a fast access hardware such as the RAM. So it is stored in the RAM, a temporary place, and may also be used in correlation with the software. It is stored temporarily. So when it is needed, it is being fetched. So a cache primary purpose is to increase the data retrieval performance. So retrieving the data retrieval performance, it makes life much more easier. So it means that, for example, if you have a back end, is that okay? And you have a front end, I'm going to explain what that means. So what it means is that in a front end, you make a request to the back end. The back end is a place that stores your data. The front end is a place that displays your data. Let's just leave it like that for now. So what happens is that the front end makes a request down to your back end, and your back end is able to fetch the data to the front end. It makes a request of a particular data A, fetch it to the front end. Now it's making another request to the data B, fetch it to the front end. So what do you think? It's going to be very inefficient. What if you have a system that when you make a request to the data, to the back end of data A, and the data A comes to the front end, then you now have a place to store it temporarily. When you need that same data, you do not need to make any request back to the back end. So it makes your work much more easier. So how cache size can affect the performance of a CPU? The more cores a CPU has, the greater the number of instructions it can process in a given space of time. So modern CPU have what they call dual core, quad core, or whatever, just to make sure a few. Now, let's see. When you go to the market, you want to get a system, they always ask you this question: what type of system do you want? Do you want a Core i5, or you want a Core i7? So what it means is that if you need a Core i5, that is 5 times the processing power. Then when you need a Core i7, 7 times the processing power. That means it's going to process much more faster when you're using a Core i7. So that means a dual core is going to process much more faster when you're using a single core, and a quad core is going to process much more faster when you are using a double core. You might be asking, what is process? A process is just a way of turning your data into information. That is the process of working on that data, turning that data into something that is meaningful. That is called the process. So in order for you to have a very fast process, you need a dual core instead of a what? Just a single core, or you need a quad core instead of just a single core. So these cores can actually affect how your system works. I've already explained that. So what is the benefit of caching? It's improved application performance. Your application tends to perform better because you are not making too much requests. What does that mean? That is, you already have the reusable data on your front end. And so when you need that data, you do not have to go back to the back end and fetch that data. So it makes the application performance. So it reduces database costs. That is your space. So let's just say a database is a place where your data is being stored. So let's leave it this way. We're still going to talk about database. So it reduces the cost of that space. So it reduces the load on the back end. It reduces the load on the back end. It's the same that the front end is always making requests to the back end. Imagine the back end has a data A and a data B, right? And the front end is asking, give me data A, and it gave it data A. Now, the way the system works is that when you give it a data A, it does not mean that the backend doesn't have it. The backend still have it. It's like making a photocopy, a copy of it, and it's giving it to the front end. So what happens is that there is still data A at the front end. Then at the back end, the front end still goes back and requests for that same data. After some time, can I have data A? The backend give him a copy of the data A, and the front end keep on asking. That's Oliver Twist. So in order for that to, to stop, the back end, the front end need to have a place where it can store the data that it was collected. So that is actually a temporary storage system. So when it needs that data A, it doesn't need to request from the make a request back to the back end. So it reduces the load on the back end. So it is predictable performance. It has a predictable performance, a much more better performance. Then it eliminates database hotspots. So these are some of the advantages of using of having a system, having the process called caching. So most system undergoes this called caching. So if you are a software developer and you are developing a software, so you need to know how to have the system working, and it must be you must put it into maximum use. So that is how it works. So I don't know if we have any question. Okay, in the absence of questions,